So here in the figure, in the given figure, if TP and TQ are two tangents, to a circle with center O, so that angle POQ is already given as 110 degree, then we have to find what will be the measurement of the angle PTQ. Okay, PTQ is equals to what? Let me draw the figure. A circle is already given. Okay, external point T is there, and from that external point we are having two tangents. One of the tangent looks like this, TT, and another tangent looks like this. Okay, TQ. Here the angle, this angle is given as a, this angle at O is given as 110 degree. And see, clearly written in the question that we are supposed to find angle PTQ. Okay, we have to find angle PTQ. That means we have to find this angle. Just a second. Wait, just a moment. Yes, let's continue. So here we are supposed to find angle PTQ. Now, anyone having any idea how can we find PTQ? If just this 110 degree is given over here, you can see my screen, right?
Yes.
Okay. Any idea how to find this PTQ? हमें सिर्फ यही पता है कि यहाँ पे ये जो एंगल POQ है ये 110 डिग्री है. Okay. So can we say that this angle will be 90 degree over here? Because
Yes.
this is the tangent, okay, and this OP is a radius. So of course this will be 90 degree, right, Galvin? Right, Maha?
Yeah.
Okay, this will be 90 degree. Now, does it looks like a quadrilateral to you? I'm talking about POQT. Can you see it looks like a quadrilateral? This,
Yes.
okay. If it is a quadrilateral, then sum of all the interior angle will be
360. 360.
okay. Yes, exactly 360 degree. Okay. Who joined? Aisha. Aisha, we are discussing circle. You was not there in the first, second class, right, Aisha?
Yes, ma'am.
Today we are having one class. I am having a extra class with Noah. She has also not attended the few classes. Please join with her. I'm going to ask my team to send the link to you. You can check the timing. Okay. So this is the question we are discussing. See, but this question we are discussing that this is the figure we are having here. TP and TQ are the two tangents, okay, and only angle POQ is given 110 degree, and we have to find PTQ. Aisha, you will be able to understand once you will attend that class. I am asking my team now only to send you the link, okay. So angle PTQ, this angle we have to find. Okay, now only I was telling to everybody that here there must be a 90 degree, okay, tangent at any point on the circle will make 90 degree with the radius which passes through. the point of contact. Okay, here also here also we'll be having 90 degree, and POQT looks like a quadrilateral. Okay, so we can say angle TPO is equals to angle TQO is equals to, both are 90 degree. Okay, write the theorem that tangent at any point on the circle makes are perpendicular to the radius through the point of contact. Write this theorem. Yes, Aisha, I am coming to you. Okay, you will be able to do this one, right? Everyone, Galvin, Ibad, are you getting it?
Yeah. Yes, ma'am.
Okay, we were just having this circle, and here 110 degree, only that is given. Okay, this 90 I have written just now. Only 110 degrees given, and that question mark, that's what you have to find. So I have written 90 here, 90 here, and I told that now it has taken the shape of quadrilateral. Okay, we are having a quadrilateral POQT, where angle P, sum of all the interior angle O plus angle Q plus angle T, the sum of all the interior angle must be 360 degree. In a quadrilateral, of course, we know that. Now we will be adding all the angles. P we have taken out, that is 90. O is already given 110. Q is already, we have taken out 90. And T we have to find. And from here you will be, this is 360. From here you will be able to find the angle PTQ which was asked in the question. Please find it. No, everyone, please find it. Yes, Aisha, there is a theorem in this chapter. Only two theorems are there. Okay. If we are drawing a line which is just touching the circle at one point, if we are drawing a line touching the circle at one point only, this type of line is called tangent. Okay. This line is called tangent line which will touch the circle at one point only. Okay, and now if we will be drawing the radius, you can understand, Aisha, this is also radius, this is also radius, this is also radius, but if you will be making this radius which will touch the point of contact of tangent, this point P is called point of contact, this because this point is only touching the circle. So this point of P, point of contact, okay, we have drawn a radius OP which is touching the point of contact. This type of radius is always, this is a special radius which will always make 90 degree with the tangent at point of contact. Getting it,
Yes, ma'am.
Aisha? Another theorem is, if you are having a point outside the circle, and from there if you will draw tangent, okay, this tangent, to tangent line we have drawn, length of the tangent, that means where the line is touching the circle. Okay, this TQ and this TP, both the length will be same. This is the another theorem. Only these two theorems we are having in this chapter. Okay, and on the basis of this two theorem we will be solving all the questions from here. In our extra class I'll be explaining everything in detail. So yes, everyone got it? Galvin, Ibad, Zanab,
Okay, that's
Maha,
70,
what you
Yes,
got?
ma'am.
70.
Okay. Angle PTQ is 70 degree. Let's move to the next one. If tangents PA and CP from a point P to a circle with center O are inclined to each other at an angle, then angle POA is equals to, okay, here figure is not given, We need to draw the figure by ourselves. So we must be very clear with each and every terminology. Then only you will be able to draw the figure over here. Let's think about it. Here it says that if tangents PA and PB, okay, from a point P, that means there is a circle and there is external point P. From that external point P, we are having tangent PA. Okay, this is the point of contact, and the another tangent is PB. This is the another point of contact. Okay, PA and PB from a point P to the circle. These two are tangents. We have drawn the tangents with center O are inclined to each other at an angle 80 degree. Okay, these two tangents are inclined with each other at an angle 80 degree. Center is O, that is also mentioned over here. Then POA. Okay, POA. This angle we need to find. How can we find it? This angle. Any idea? Only two theorem we know. Whatever I told you, Aisa, you can also think about it. Okay, everyone will, of course, will be thinking, and you can also think about it. Only two theorems we have, and remaining everything you, whatever you know already from class 9 concept, you can apply it over here. Can anyone? Can you tell me how we'll be finding this angle POA? Is it even possible to find POA with only this much of information?
Can
We
you
are
repeat?
having a,
Yeah, like
yes,
angle
please.
PAO will be 90 since radius will be perpendicular to the tangent. And then like you can take angle APO as half of 80.
APO as half of 80. Why will be taking it as half of 80? Because these two are congruent triangle, right? Right?
Yes.
Because triangle PO, yes, ma'am, it's perfect. Triangle POA and triangle POB are congruent triangle. You can say that these two are congruent triangle. Why it's these two are congruent triangle? Because we know that now you can write also that we know that there is a common side. See, so many congruency criteria. Maybe you are using SAS, another student is using angle side angle, whatever. At least congruency you will be able to prove easily. Okay, so you can say here 90 degree will be having in this triangle angle A is 90 degree, in that triangle angle B is 90 degree. Okay, both are 90 degree. That we know. There is a common side also, OPOP. Or what else? Yes, what else?
Radius?
Radius. Okay, OA is equals to OB. That's why these two angles will be seen. Okay, so radius of the circle, we can say that angle APO will be half of 80 degree. Here you must write it by CBCT. These two angles are same. That is angle APO and angle BPO. These two are same by CPCT. Everyone getting me what I am writing over here? Galvin, Ibad. Okay.
Yes.
Now you can focus on this triangle and easily you will be able to find this angle O. Okay. You can focus on this triangle. Please find it and tell me by angle sum property what is this angle O. First thing first, read the question very carefully. When I am writing the question, you are supposed to sit and read the question. So here it says that tangents are there, two tangents are there, and the angle is given in between both the tangent. There is an angle that is 80 degree that is given in the question, and we have to find this we have to find this black colored angle which I have shown over here, this question mark one.
50.
Okay. Okay. So now only Maha said that here we'll be able to find, we'll be able to say that if total angle is 80, then that part will be 40, this part will be 40. Getting it, Galvin?
Yes,
Galvin?
ma'am.
Okay. So if this is 40, this is 40, then easily we can focus on this triangle APO and we can find angle O will be 50-degree, right? That's what we have to find. Okay, angle POA. Please don't write angle like this. Angle O, don't write like this. Write the proper name always, POA. Since I'm just explaining over here, you can see sometimes I'm writing the angle like this only. Angle O, angle A, angle B. But please don't write the angle like this. Always write the specific name, the proper name. Okay, let's move. Any confusion so far to anyone? Aisha, are you understanding, Aisha? Even though you have not attended the class, but still you are getting it, right?
Yes, ma'am.
Okay, Ibad, you are getting.
Yes, ma'am.
Galvin.
Yes, ma'am.
Now the next question is prove that the tangents drawn the end of diameter of a circle are parallel. Okay, it says that prove that tangent drawn at end of diameter. Let's draw a circle. You can draw any diameter. I'm drawing diameter like this. You can draw a horizontal diameter. It's completely your wish. Okay, you can draw it the horizontal line also as a diameter like this. Okay, diameter. Prove that tangent drawn at the end of diameter, at the end point of the diameter when we are drawing the tangent. We have to prove that this two tangent, this line AB and this line CD, okay, these two are parallel with each other. That's what we have to prove over here. Everyone getting it? What exactly we have to prove here? Prove that the tangent drawn at the end of the diameter, tangent drawn at the end of the diameter, these two tangents are parallel with each other. That's what we have to show over here. Any idea how to show it? Can we say that this angle will be 90-degree? Can we
Yes.
say
Yeah.
that? And we can also say that this angle will be 90-degree. And if you are having two random lines, okay, parallel or not parallel, you don't. Two random line and there is a transversal. And interior angle on the same side, if sum is 180-degree, that means both the lines are parallel with each other, yes or no?
Yeah.
Okay, if we are having two random line, if co-interior angle sum is 180, then of course both the line AB and CD must be parallel with each other. Either you can use co-interior angle or you can say that this is 90, okay, and this is also 90. So you can say that alternate interior angle is same, and hence this two line must be parallel with each other. Am I making sense to all of you?
Yes.
Okay, so whatever reason you give, easily you will be able to say these two are parallel with each other. Galvin, Aisha, Ibad, are you getting it? Because Maha and Zanab has already responded.
Yes, ma'am.
Getting
Yes.
it? Okay. Who joined? Okay, Faizan, you joined. This is this is your first class from Circle, right?
Yes.
Okay, please. I'm just today we are having one extra class where I'm going to start the circle. I'm asking my team to send you the link, the timing as well. Please try joining over there. Okay. So yeah, let's start. So we'll be writing it. Let me write. We know we know. Let's say alternate interior angle or whatever co-interior angle your wish. I'm taking alternate interior angle. So we can say that this is 90. We can say that angle D, suppose the point of contact is P over here and the point of contact is Q over there. I'm coming to you, Fazal. DPQ, okay, is same as angle AQP. Both are 90 degrees. Why? Here tangent at any point of the circle is perpendicular to the radius to the point of contact. Here we can say that AB and CD are two lines. Now AB and CD are two lines and PQ is transversal such that, okay, such that here this angle, okay, DPQ, and there AQP, both are same, which is nothing but just a pair of alternate interior angle. Therefore, AB must be parallel to CD. Okay, please do it. Yes, Fazan. Here only two theorem we are having. See, this is the problem we face in our, like, if you are missing any class, you will not be getting it. And you have missed not only one class, two, three classes. So I need to think about it, that what concept I'll be giving over here, so that at least whatever we are discussing for now, extra class will be arranging, but at least whatever we are discussing over here, that will make sense. Okay. So yes, let's keep it aside. Yes, Faizan, please focus here. Two theorems are there, which is very important over here. And all the question in this circle chapter we are doing with the on the basis of this theorem. Okay, one of the theorem is one of the theorem is, suppose you are drawing a line like this. This type of line is called tangent line, which is touching the circle at one point only, and this point is called point of contact. This point of contact, okay, if you will join with the center, it will always make 90-degree over here. Okay, this is one of the theorem. Getting it, Fazan? And the another theorem is, from
Yes.
any external point P, if you will draw tangent, only two tangents you will be able to draw like this. This both the tangents, okay, it must be tangent. This both the tangents length will be same. Okay, tangent drawn from external point are always equal in length. PA and PB, these two tangent till the point of contact, you have to measure the length. that length will be same.
Teacher,
Okay.
this one I know.
Okay. This one you know. These only these two theorems we are having. Great. If you know that, it will help you. Okay. Let's take the next question. Previous one was clear to everyone, right?
Yes.
Let's move.
Teacher, I don't think I need an extra class because I I did this chapter in the school.
Okay, you already understand. Okay, that means the question which I'm going to write on the screen, it will make sense to you. So yeah, that's great
Yes.
then. Okay, prove that the perpendicular at the point of contact to the tangent to a circle passes through the center. Okay, let's try to do it. Let's understand what the theorem says. Prove that the perpendicular at the point of contact, when we will be drawing a tangent. Suppose we are drawing a tangent. Okay, this is the tangent PQ. Suppose the point of contact is the point M. Okay, now let's read. Prove that the perpendicular at the point of contact, if we will be drawing the perpendicular at the point of contact, okay, to the tangent. Of course, point of contact terminology came from the tangent only. Okay, to a circle passes through the center. We have to show that if we are drawing the perpendicular, okay, at this point M, if we are drawing the perpendicular, that perpendicular is passing through the center. What will be the approach for this? How we'll be saying it? That the perpendicular which we are drawing over here, that must pass through the center. How we will say that? Any idea? Suppose it is not passing through the center. Okay, let's try thinking about it. Written part, I'll be writing it. Okay, let's try understanding it. Let's try understanding first. Focus. Suppose we are saying that at this point of contact M, we are drawing a perpendicular. Okay, we are drawing a perpendicular, but that perpendicular is not passing through the center. Okay, let's use the method, contradictory method. Okay, a contradiction we will take and we will try analyzing what can be done over here. So let's think about it. Suppose we are taking a point, suppose we are dropping a perpendicular over here. It doesn't looks like a perpendicular, but let's assume that it's a perpendicular. Okay, it's a perpendicular. This is a perpendicular. Okay, I wanted to draw it slightly more inclined. Let me draw, because now only I'll be joining this point of contact with the center also. So okay, suppose we tried dropping the perpendicular at point M. Okay, we tried dropping the perpendicular at point M through any random point, any other point R. Okay, this is the perpendicular we are saying. Don't worry, don't focus, don't worry with the figure that no, it doesn't looks like perpendicular. A contradiction we have taken, that we are dropping a perpendicular. Okay, it's a perpendicular and it is not passing through the center. What we have to prove over here, we have to prove that perpendicular whenever we will drop, at the point of contact, it must pass through the center. And contradiction we are taking that, okay, let's assume that it is not passing through the center. Okay, it is not passing through the center. This RMP, this is 90 degree. We have drawn any random line. We are calling this a perpendicular at the point of contact. And yeah, according to our assumption, it is not passing through the center. Okay, this is what we have taken the assumption. Now what we can do, we will join the radius over here, center, and this we will join, and we will say that we know that, okay, this theorem is actually very simple. We will be taking the contradiction and we will be writing the theorem which we already know in this chapter. Only two theorems we know. Okay, we will be writing, we know that tangent at any point, tangent at any point, the circle is perpendicular to the radius through the point of contact. Okay, this theorem we have learned very well. Okay, let's write it. Let's write it. We know this theorem, and according to this theorem, angle OMP, that is 90 degree. Okay, according to this theorem, this is 90 degree. According to our assumption, this is 90 degree, which cannot be true. Right? Right?
Yeah.
Okay, these two are completely different scenario. It will never ever be possible that this is also 90, angle OMP is also 90. What we are saying, we are saying that angle OMP, this is also 90, and the complete one from our assumption which we have taken, this is also 90, this is also 90. It is not possible that two lines are there and both are making 90 degree with the same line. It is not possible. So we will say that hence R and O is the same point. Looks different in the figure, but according to the whatever we are getting the outcome, according to our outcome, R and O must be the same point, and hence the theorem that the perpendicular at the point of contact to the tangent must pass through the center. Getting it? It is very simple. It is very simple. It looks like why we are doing so, what we are doing over here. But think about it. Okay? Think about it. We are having a circle. Okay? We already know one theorem which supports. We already know one theorem which supports that, of course, the radius which is touching the point of contact, that radius will be perpendicular to the tangent. We know that. Here we have to prove a theorem which says that, prove that if you will be dropping a perpendicular at the point of contact, that perpendicular must pass through the center of the circle. That's what we have to prove. So basically, whatever we know, the theorem, that is only enough. Okay, the theorem which you know, that is only enough to explain that, yeah, we know that that radius through the point of contact will always be 90 degree. But only theorem we'll be writing and we'll say that, yeah, we are done. So let's try creating a condition. We are saying that no. Okay, that is okay. We know the theorem. There is another point. There is another point in the circle which is making 90 degree at the point of contact. But we know this theorem also. That means that is also 90. This is also 90, which can't be true. Okay, it can't be true. That means both are same point. Hence the theorem is proved. Am I making sense to all of you? Yes or no? Are you getting it?
A little bit.
Yes, rest of the student, are you getting it? I'm coming to it. Okay, we'll be discussing it. Okay, for now, let's keep it aside. Let's discuss the another one. We will come back to it. Okay, we will come back to this theorem. Let's discuss the another theorem, which like target I have set. Let's discuss the other theorem, and then I'm coming to this one. If not today, then the next class I'll be starting with this one. Okay, let's discuss the other questions also. This question will you be able to do? Please see carefully. Yes, yes, everyone, try it. You will be able to do it. Please try it. The length of the tangent from a point A. That means a circle you are having, and there is a point A outside. Okay, A. At a distance 5 centimeter from the center. From here, we are drawing a tangent. That's why it says length of tangent from A. Okay, till the point of contact, you have to measure the distance always. So whenever I am saying length of tangent, that means the distance PA from the external point till the point of contact. जब भी हम tangent का length measure करते हैं तो हमारे पास एक external point होगा, वहां से लेके point of contact तक length measure करते हैं. That length is called the length of the tangent. तो अगर यहाँ पे length of the tangent की बात हो रही है, that means PA की बात हो रही है. एक एक्सटर्नल पॉइंट ए से जो हमने टैंजेंट ड्रॉ किया, जहां भी टैंजेंट सर्कल को टच कर रहा है वहीं तक के लेंथ की हम बात करते हैं. ओके, सो द लेंथ ऑफ टैंजेंट फ्रॉम अ पॉइंट ए, फ्रॉम दिस पॉइंट एट द डिस्टेंस 5 सेंटीमीटर फ्रॉम द सेंटर. ये जो पॉइंट ए है इसका डिस्टेंस सेंटर से दिया हुआ है 5 सेंटीमीटर. इज 4 सेंटीमीटर. क्या 4 सेंटीमीटर है? ध्यान से पढ़ो, ये क्वेश्चन बहुत सिंपल है, बट बस फिगर बनाना. ड्यू टू द स्टेटमेंट only the construction part can confuse you. The length of the tangent from this that whole story is 4 centimeter. Okay, the length of the tangent is 4 centimeter. Are you getting it? The length of the tangent from a point A at a distance 5 centimeter from the center of the circle is 4 centimeter. That means कोई एक point A है, ओके, जहां से जो सर्कल के सेंटर से 5 सेंटीमीटर डिस्टेंस पे है, उस पॉइंट ए से लेंथ ऑफ द टैंजेंट 4 सेंटीमीटर है. इतना तक सबको समझ
So you
में
have to
आ रहा
find
है?
OP by Pythagoras.
Yes, everyone understanding the statement at least?
Yes.
Yes. Aisha and who is this? Zanab, Galvin, Fazan, are you getting it? Ibad.
Yes.
Okay, so we have to find OP over here, and we know that the theorem which I have written over here, this theorem, the tangent at any point on the circle is perpendicular. Okay, is perpendicular to the radius through the point of contact. So this will be 90 degree, and you are having a right angle triangle. Easily you will be able to find OP, right? Shall I leave this question?
Yeah.
Let's do the next one. We'll be
Sir, I
discussing this
got the
question
answer as
again.
3 centimeter.
Okay, you got the answer as well? Great. It will be 3 centimeter. Let's move. Now the next is a quadrilateral ABCD is drawn. To circumscribe a circle, prove that AB plus CD is equals to AD plus BC. Okay, we are having a circle. Figure is given already. Okay, I'm not drawing the figure by myself. It is already given. Okay, this type of figure is given in the question. Here the points are mentioned as a R, S, Q, and P. C, D, A, B. A quadrilateral ABCD, which you can see over here, that is already given. Okay, to circumscribe a circle, that means it is circumscribing the touching the circle. Okay, this quadrilateral is touching the circle. It is just completely all around the circle. That's called circumscribe the circle. Okay, prove that AB plus CD, what we have to prove, हमें prove करना है कि ये जो side AB है plus CD ये जो side है is equals to AD plus BC. ये बहुत ही फेमस क्वेश्चन है. हाउ विल बी प्रूविंग इट? बहुत ही सिंपल है. ध्यान से देखो, ध्यान से देखो. हमें क्या ये समझ में आ रहा है कि ये एक एक्सटर्नल पॉइंट डी है. यहाँ से अगर हमने ये टैंजेंट ड्रॉ किया डी आर एंड डी एस, तो ये दोनों टैंजेंट का लेंथ इक्वल होगा. कैन वी से दैट दैट टैंजेंट ड्रॉन फ्रॉम
Yeah.
एक्सटर्नल to the circle will be equal. We can say that, right? अगर हमने एक्सटर्नल पॉइंट, कोई भी एक्सटर्नल पॉइंट से दो टैंजेंट्स ड्रॉ किए, दोनों टैंजेंट्स आपस में इक्वल लेंथ के होते हैं. हमें ये पता है, हमने कन्ग्रुएंसी से प्रूव किया था फर्स्ट और सेकंड क्लास में. ओके, तो हमें ये पता है. और क्या हमें पता है? सिमिलरली हम सारे ही ऐसे एक्सटर्नल पॉइंट्स को कंसिडर करेंगे और केयरफुली लिखेंगे. ओके, तो एक और हमें पॉइंट यहाँ पे दिख रहा है. सी भी एक एक्सटर्नल पॉइंट है और यहाँ से भी दो टैंजेंट्स ड्रॉ किए हुए हैं. सी इज ऑल्सो एन एक्सटर्नल पॉइंट और यहाँ से भी दो टैंजेंट्स ड्रॉ है. ये सी आर एंड सी क्यू, ये दोनों का लेंथ भी आपस में इक्वल होगा. वी विल बी राइटिंग इट, बट हमें केयरफुली लिखना होगा क्योंकि एट लास्ट हम सारे इक्वेशंस को ऐड करने वाले हैं. ठीक है, तो ये जो सी आर है, जिस साइड में हमने डी आर को मेंटेन किया है उसी साइड में हम सी आर को मेंटेन करेंगे ताकि हम बोल सके इक्वेशन 1 एंड 2 को ऐड करें तो डी आर प्लस सी आर मिलके सी डी बना रहा है. एम आई मेकिंग सेंस? एम आई मेकिंग सेंस?
Yeah.
Okay, so we are writing it that external point D from there the length of the tangents are same, but carefully हम sides भी maintain कर रहे हैं ताकि लास्ट में हमें जाके confusion नहीं हो कि हमने ऐड तो कर दिया बट हमारा आंसर तो आ ही नहीं रहा है. ओके, सो केयरफुली विल बी मेंटेनिंग द साइड. जिस साइड में मैंने डी आर लिखा था उसी साइड में मैंने सी आर लिखा है क्योंकि एट लास्ट मैं ये इक्वेशंस को ऐड करने वाली. Okay, now we are also having this B, and from this external point B also we are having two tangent BQ and BP. We'll be writing this two tangent will also be of same length. दो ही थ्योरम है इस चैप्टर में, फर्स्ट 90 डिग्री वाला एंड द नेक्स्ट वन इज एक्सटर्नल पॉइंट से टेंजेंट ड्रॉ करते हैं, दो टेंजेंट मैक्सिमम ड्रॉ हो सकता है और दोनों का लेंथ आपस में इक्वल होता है. ओके, सो PQ एंड BP. हियर आल्सो वी विल बी वेरी केयरफुल विद द साइड्स. तो ध्यान से देखो, PQ CQ वाले साइड में होना ही चाहिए, तभी जाके दोनों ऐड होके this complete side will be getting according to the proof which we have to prove over here. Okay, so BQ को मैं CQ वाले साइड में लिख रही हूँ और BP को इस साइड में लिख रही हूँ. Am I making sense?
Yeah.
Everyone
Yeah.
getting it? Now from external point A, same story. AS and AP, this two will be same, but AS को उसी साइड में लिखेंगे जहां DS है, या फिर AP को उसी साइड में लिखेंगे जिस साइड में BP है. तो ध्यान से देखो, AP को हमने लेफ्ट में लिख रखा है, BP को हमने लेफ्ट में लिख रखा है, तो AP भी ऐसे लिखेंगे एंड देन विल बी एडिंग ऑल दिस फोर इक्वेशन. आयशा, गैल्विन, फजान, everyone getting it? Now adding
Yes.
1, 2, 3. Aisha, are you there?
Yes, ma'am.
ऐड करो DR CR. क्या मैं जो जो समझा रही थी कि हम कैसे लिख रहे हैं, ये समझ में आ रहा था आयशा?
Yes, ma'am.
DR प्लस CR प्लस BP प्लस AP, क्या मिलेगा हमें लेफ्ट साइड में बताओ? DS प्लस CQ प्लस BQ प्लस AS. बहुत ही सिंपल थ्योरम है, बहुत ही फेमस थ्योरम है, बहुत बार प्रीवियस ईयर क्वेश्चन पेपर में आज ये वाला थ्योरम मिलेगा. सी केयरफुली, DR प्लस CR हमें मिला है यहाँ पे, दैट मीन्स वी कैन राइट डायरेक्टली DR प्लस CR मीन्स CD. लेट्स राइट इट. ये दोनों मिलके तो CD बना रहे हैं. BP प्लस AP, ध्यान से देखो, BP एंड AP मिलके क्या बना रहे हैं? AB. ओके, सिमिलरली दूसरे साइड में DS एंड ये लास्ट AS, ये दोनों मिलके क्या बना रहे हैं? DS प्लस AS. ध्यान से देखो, here is A, DS plus AS will be AD or DA, and CQ plus BQ, CQ plus BQ is BC, and we are done with the proof. Everyone getting it? यही हमें प्रूफ करना था. देखो, a quadrilateral, we are having just a quadrilateral which is circumscribing the circle. Okay, and hence we have to show this. Is it crystal clear to all of you?
Yes.
Is it crystal clear? तो एक थ्योरम आज के क्लास में मैंने छोड़ा है. ओके, मैं फिर से उसे एक्सप्लेन करूंगी दूसरे क्लास में. ठीक है? Is it okay?
Yes.
Okay, so yeah, this is how we're doing this. So yes,